Let's take a look at Cisco's Secure Network Access. This is an architecture based on several technologies. It combines the switch, the wireless LAN controller, and ICE. It includes the following features. It provides authentication of wired and wireless users using 802.1x, MAB, and web authentication. We can deliver policy-based authorization based on downloadable ACLs, VLAN assignment, or security group tags. And we've got broad client support for native operating systems and third-party supplicants. So what that means is we have a kind of a common framework to apply when users come into the environment. So on the left side, here we've got a user. And the user wants to get in, and we want, if we look at the framework for 802.1x, they say you have a supplicant, an authenticator, and an authentication server. And the authenticator, I think of like the old movie, Who Framed Roger Rabbit. In Roger Rabbit, he's trying to get into this nightclub, and he knocks on the door, and the door's got a kind of like a peephole in it that slides open. And they slide open the door, and they say, "Who goes there?" And you can't get in. It's just somebody kind of peeking through, want to talk to you. That's what happens with our firewall. It's the door guy. It's the gatekeeper that says, "Who's trying to get in over there?" And the way that we've been looking at this for remote access VPN, it's not a whole lot different if this were a switch for wired connectivity that was local, or even an access point connected to a wireless LAN controller. Because in all three scenarios, you've got a user on the outside, again, this is your supplicant, that wants to get into the network. And at the perimeter, our gatekeeper could be a wireless device, it could be a firewall, it could be a switch. In any of these scenarios, we go, "Hey, who goes there?" They're going to pass us their credentials leveraging the extensible authentication protocol. Even Ike version 2 can leverage EAP. So this is real kind of commonly used technology. EAP is a layer 2 mechanism for passing credential data. Once it gets to the authenticator, you're like, "My username is Bob, my password Cisco123. Like, we don't store usernames here. Each of these devices is going to pass it back to the exact same AAA server. So maybe this is your ICE deployment, and our switch, our firewall, our wireless LAN controller can all point back here and authenticate the user in the same way. Additionally, you could pull this off using a native client. There's a 802.1x supplicant built into most operating systems, but you can get some more features out of it if you use Cisco AnyConnect, which also works on many operating systems. So what's cool is from a user perspective, when they authenticate to the network, they'll use AnyConnect, and it'll kind of feel the same whether they're local or remote. This is really neat. So 802.1x is used as an access control protocol for both wired and wireless clients. If you remember, long ago in the wireless world, they had WEP. WEP was insecure, it wasn't thought out that well, and we needed a better solution. As they were baking this better solution, they were trying to come up with 802.11i, which was kind of a cornerstone of WPA2. And what this tied into was a much more intelligent user authentication mechanism. That mechanism, which we had to build for use within the LAN, the local area network, this technology, I think, really came from the WAN. You see, in the old days with dial-up, we had PPP, the point-to-point protocol. This was used on traditional PSTN circuits, ISDN, ADSL, even some cable modems did PPP over Ethernet. The main thing about this was it was layer 2 authentication, but it was very, very old. It was pretty dated. PPP evolved to become the extensible authentication protocol. And it was really built for LAN use. We were trying to solve 802.11 issues when this was kind of drummed up. But we said, well, if we use it for wireless, can we use it for wired? And they said, absolutely, it's the same thing. And then you see with Ike version 2, they liked EAP so much that they wound up baking it in over there as well. So the extensible authentication protocol is layer 2 authentication, just like PPP was. It's a way to authenticate to the network. And what makes it so cool is it works without an IP address. So you try to get on the network, and the network's like, hey, who goes there? You're like, oh, nobody, just me, just doing some DHCP real quick. And they're like, before you do DHCP, who are you? Because once we figure out who you are, That goes back to the radio server. Now here comes your AV pair. That AV pair is going to have your VLAN. So once we know who you are, we can do dynamic VLAN assignment. Once your VLAN's set up, you'll do DHCP, and you'll get an IP address that's appropriate for someone that works in network support because you work in network support. And we know that from authentication and from group membership. Really, really gorgeous the way this all ties together. Sometimes this is described as identity-based network services. Here they're just calling it identity-based authentication and authorization. And the use cases are very broad. I mentioned before that we use a lot of these underlying technologies within Cisco's AnyConnect Secure Mobility Client. It supports .1x, it supports MAB, MAC Authentication Bypass, and web authentication. These are 3 different ways to log into a network when we start looking at what our switches and wireless access points can do. 802.1x is ideal. I'd love for everybody to use that. But I've got a badge reader, or I've got an IoT device, and I'm sending it EAP logon requests, and it's not doing anything. So MAC Authentication Bypass goes, oh, well, devices with these MAC addresses can bypass 802.1x logins. This is a requirement for older devices that can't do .1x, but it's also a security risk because anybody who knows that that's going on or suspects that this is going on can change their device's MAC address to one of yours and try to bypass. Something to be aware of. So remember, for MAB-enabled devices, we can push down very strict ACLs. We can also dynamically allocate specific VLANs and do some isolation there. Additionally, you may have clients coming into the organization where you have a real person sitting there and they're a valid user, they just don't have .1x configured in their OS. In that case, we can hijack a web request. They try to go out to Google perhaps, and when they try to go out, we go, hey, we haven't authenticated them. Steer their web session into a portal, ask them who they are, there we can authenticate them, and now we can push down a policy appropriate for that user.